Okay. So this is Georgia and Chloe. Um, what we're doing today is we're looking at how to use an interactive, looking at Drosophila, and we're doing different crosses. So first thing you need to do is you need to type Science Courseware into your browser, which is highlighted up the top, and go to this website. So when you go to that website, you might get a little bit of an error, but you can just click run this time and it will work, and you'll come to this page. What you need to do is you just want to enter as a guest. You don't need to create an account, so just click where it says that. You might get this error come up. Just click run this time and Adobe will work for you. Georgia will run you through how to start off the activities.
Awesome. Okay, so firstly, what you want to do when you're doing an experiment on Drosophila fly, which is what we're doing today, is you want to order your flies. So you want to get your parental generations. Sorry, I went through that very quickly, but yes, you want to click on to order flies. So you've got your female and you've got your male. So one of them you want to keep as a wild type, because we're going to be doing a cross of a wild type across a homozygous recessive. So here we've got your female as a wild type, which is wild type for all these different traits, and your male, we will choose two separate traits to show a dihybrid cross. Now, issue with this is that you want to make sure that the two traits you're looking at are on separate chromosomes. If they are linked, then our ratios will be different to what is expected. So in this one, we're just going to randomly choose vestigial. So that's the wing size, which I would say shape, but apparently it's size. And maybe we'll choose eye shape, and we'll say Atlas. So now we've got two separate homozygous recessive traits. And we will, two recessive traits, and the fly itself is homozygous. So then we'll click to add to cart. So we've got the male added to cart, and we'll also click the female added to cart. So you click on your shopping cart.
And the female there was just a wild type.
Yeah,
and we can see that in our cart now.
Yeah. So this is what we have. We've got the homozygous recessive and homozygous dominant.
So if you've actually done the recording and you've posted,
and we really want to order these flies.
Yeah, so we want to order them from the lab, so we'll say yeah.
Here we are back in the lab.
Our flies have arrived in this box, so let's click on the box and see what we ordered.
So we're pouring, we've got the female
wild type,
and the male.
Upload this to our lab now.
So we've put them both in the incubator, and there they are in our little fridge there.
These would be our parental generation.
Yeah.
And here we have the mating jar. So the mating jar contains one of each of these. Oh, well, lots of each of these, but we're crossing these
We're producing offspring, yeah.
In the mating jar, we're getting them to mate, and then we're getting them to produce offspring.
In the mating jar. So let's incubate that one too.
In it goes. 2 weeks past, as you can see.
Look at those babies.
Look at that. Oh, yummy.
Okay, so as you can see, we've got lots and lots of offspring.
So
in
this is
that
what
jar
has
now.
happened in this incubating
Process.
Okay, so we open up the door, and here we have our F1 generation. Click on the F1. Chloe, what is the genotype of our F1 generation, do you think?
It's a dihybrid cross, so they're all going to be heterozygous. Wouldn't you say so, Georgia?
I would agree. What about their phenotype?
Well, their phenotypes are probably going to be the same as well. No, they're
do you
going to
mean?
be different, aren't they?
Their phenotype would be the wild type. So they would show the...
They would all be the same.
But yeah,
However, it's interesting when we sort these flies because we're not sorting them based on the phenotype, are we? And this is where you might get confused because we're also sorting them, as you'll see in a moment, into male and female groups.
Yeah.
So you might go, oh, we have 2 different phenotype groups. No, that's not correct. As you can see, all the flies look the same, so we have one phenotype. But at the moment, we've just separated them into males and females.
Yeah.
And we've got a ratio of 1 to 1, which is what you'd expect.
For male and female, roughly.
Yeah.
And yes, they all will have the phenotype of the wild type, as you can see in this. Here you can see
Yep, there
that
we
it
go.
has the wild type phenotype because that was the dominant trait.
Yep, and our other group as well.
So what we'll do is we'll send this data to the computer, but we don't need to go and have a look at it just yet because we can pretty much see everything that we want to see here. So return back to the lab, and what we want to, no we won't. Yeah, we will. So we didn't actually return back to the lab. We want to stay in this window. So don't return back to the lab. Alright, so what we want to do is we want to click on and have a close-up look. So here we have the male wild type, and what we want to do is we want to do a cross of the heterozygotes. So we want to click into a new mating. So we've added the male into a new mating jar. You want to click zoom out here.
Now we're going to click on the females.
Yeah, do the same with the female.
So here's our female. We're going to use out this heterozygous in a new cross.
So what we should have done now is had each of these two in a new cross, and so we're going to be crossing the F1 generation to produce an F2. Here it is.
And here it is. So let's go ahead and incubate that. 2 weeks later, look at them all. That's life, Georgia.
It's beautiful.
There we go.
Okay, so we click on this one, and then we want to click on the incubator to open up.
And then we
So
want
we
to
have
select
our P.
our F1, and this one's our F2. So let's go ahead and click on that one. Knock out our flies again. This doesn't kill them, it just knocks them out. And we're going to sort them again. So let's go ahead and sort our flies. What would we expect this time, Georgia?
I wouldn't have expected that.
Well, that's a lot of groups, isn't it?
Yeah,
So
but
why do we have so many groups here?
we have to remember to take into account both male and female. So what would be our expected ratio for a heterozygous cross and a dihybrid cross?
Well, if we're doing a dihybrid cross, then we'd expect a ratio of 9 to 3 to 3 to 1, wouldn't we?
Yes, yes. Remember that a monohybrid cross is 1 to 1 to 1 to 1 for a heterozygous cross. However, in dihybrid, because we're looking at two separate ones, we'll have different ratios. Alright, so we're looking at this as it is, and it doesn't look as clean and neat as we'd like. So what we'll do is we'll send the data to the computer. Send it to the computer. Alright,
So we're in the computer.
and we want to go analyze the results. So here we have them, but first we want to click this here.
We want to ignore the sex because these aren't X-linked traits that we're looking at. And if we analyse those numbers, we get a pretty nice ratio there, don't we? So we might see that we actually get that 9 is 3 is 3 is to 1.
Yeah, 9 to 3 is 3 to 1. Just to specify, this is the phenotypic ratio.
Yes, the phenotypic ratio.
Phenotypic ratio.
So this is a really nice way to sort of have a play with the Drosophila and see what sort of crosses you can make.
And really expose yourself to what it would be like to study genetics after school.
in a scientific
There we
environment.
go.
Yeah.
That is exactly what I was thinking. Thank you, Chloe.
Thanks for listening.
I hope you enjoyed. Goodbye.